Hey Math 8, we are moving along with Chapter 6 today. We are moving to Section 6.4 where we are going to learn to find the rate of change. And we will use stuff we already know to do this, so let's do it. You can see that our goal today, our objective, is to find the rate of change from a situation, from a table, from a graph, or from an equation. We can find a rate of change. So first, let's learn what a rate of change is. The rate of change is how much a quantity, my connection is not too good. A quantity increases for each 1 unit of another quantity. Now that sounds a little weird, I know, but it's how much one quantity goes up for each 1 unit of another quantity. Rate of change is found by dividing. You divide one quantity by the other. And sometimes this is called a unit rate. I will explain why in just a second. So let's look at some relatively easy examples. For example, if you drove 400 miles and used 16 gallons of gas, what is the rate of change? Well, you simply divide, right? You divide 400 miles by 16 gallons, and 400 divided by 16 is 25. 25 miles per gallon. All right, now look at what we did. What we have seen here is how much a quantity, in this case our quantity is miles, how much that increases for 1 unit of another quantity. Our miles increases by 25 for every 1 gallon of gas. And how did we find that? We found it by dividing, right? That's what a rate of change is. A rate of change is how does this quantity change for every 1 unit of the other quantity? And that is why it's called a unit rate, because it's how much it changes for every 1 unit. Let's look at another one. $29.94 for 6 pounds of turkey. My wife likes to get turkey at the store. We have it for lunch or dinner. So what would the rate of change there be? So it would be $29.94 divided by 6. And if you divide that, you get 4.99 per pound. I guess most people would write that with a dollar sign, dollars per pound like that. All right, and again, we just got that by dividing. So for turkey, the rate of change is $4.99 for every 1 pound, every 1 unit. That's what the important thing is. How much change per 1 unit? Let's go to the next one. Many of you are right in the midst of this right here. You've grown 13.5 inches in 3 years. So the rate of change there would be 13.5 divided by 3. That is 4.5 inches per year. The rate of change. All right, so we have seen that you calculate the rate of change when you have 2 quantities by dividing. That's the most basic kind. Here's what we want to do. We would like to learn how to find this rate of change for any situation. Whether you have a table or a graph or an equation or just a situation, can you find the rate of change? Well, I have great news for you guys. Here is the good news. You already know how to do it because rate of change is something we have already been finding. Did you know that? It is one of the key elements of a linear situation. The rate of change is the same as the amount of increase/decrease each time. That is what rate of change is. We've already been finding it. When we were writing linear equations, right, we had to find the beginning amount and we had to find the amount of increase each time. And the amount of increase each time is the rate of change. It's how much something goes up each 1 unit. So let's see some examples. All right, so this first one is a situation, right? Uber charges a one-time pickup fee of $4 for every ride, as well as a $1.10 charge for each mile. Find the rate of change. Well, you might remember from the last several sections, if I was going to write an equation for this, that this would be my beginning amount. All right, and this would be the amount of increase each time. In fact, my equation would look something like, right, v plus mx. So in this case, the cost of getting an Uber would be 4 plus $1.10 times x. But here's the thing. I'm not trying to write an equation. I am just trying to find the rate of change. And the rate of change is the amount of increase each time. Oops, change. So they told me the rate of change. It's $1.10. $1.10 per mile. Or probably better if it's written that way. $1.10 per mile. That is the rate of change. Here is a basic situation like we saw at the top. While cutting lawns in July, I think I should have had a comma there. While cutting lawns in July, Colin earned $182 for cutting 7 lawns. Find the rate of change. So to find it, right, to find rate of change, I just divide. $182 divided by 7 lawns. 182 divided by 7, I think that is 26. So the answer here would be $26 per lawn, right? 1 unit. We have found the rate of change. Remember, sometimes this is called the unit rate because it's the amount per unit. $26 per unit. In this case, the units is lawns. $26 per lawn. All right. How about example 3? You have an equation. Have you guys ever rented a U-Haul before? I've done this several times when I have moved or had to move something. U-Haul charges a one-time fee for every truck rental, that's true, as well as a charge for each mile you drive. The equation y equals $1.19x plus 29 represents what U-Haul charges to rent a truck. Find the rate of change. All right, well, you might remember that typically we have written equations like this. Y equals b plus mx. Now they kind of switch things around on us over here. They put the number attached to the x first. Now, typically, we would have written this like this, 29 plus 119x. But they switched it around on us, didn't they? We are not going to let that confuse us. So even though they wrote it this way instead, we know that the amount attached to the x is the amount of increase each time. And the number that is not attached to the x, what's that number? That is the beginning amount. Well, like I've said several times, if all we're doing is trying to find the rate of change, we don't care about the beginning amount. All we care about is the amount of increase each time, because that is the rate of change. So in this case, how much does U-Haul charge in dollars per mile? They charge $1.19 per mile. All right, I keep trying to emphasize the amount of increase each time is the rate of change. And you've done this before. Let's look at a table. I think a table is the hardest kind. So it says here, Lydia is saving money each week. Lydia's savings are represented by the table to the left. Find the rate of change. So we just went over how to do this one last notes, right? This table is a little tricky because it doesn't go by ones. So it's a little tricky to find how much it increases each time, but we can do it. So what you do, right, is you find out how much is the y increasing. Well, from 55 to 115, that is an increase of 60. And if I did it again, it's also an increase. So the y is going up by 60 each time, while the x goes up by 4. I think I'm going to write that down. So y goes up 60. Should I write dollars? Now let's put a symbol. $60 each time x goes up 4. Well, if y is going up 60 when x goes up 4, how much does y go up each time? So I could divide 60 by 4 to get how much it goes up each time. And so let's see. It goes up 15 each time. All right, see, again, I just divided. Doesn't that make sense? If it's going up 60 in 4 weeks, dividing by 4 tells me how much it goes up each week, right? So I took the 60 and I divided it by 4, and I got it goes up 15 each time, or in this case, that would be each week. So the answer is, how much is, or what's the rate of change? Let me write that down. The rate of change is $15 per week. All right? We okay with that? All right, I've got one more, and it's a graph. Now, let's see. The graph below represents how much Planet Fitness charges their members. They charge a one-time sign-up fee, that's true, and a monthly membership fee, that's true. Okay, so here's the thing about a graph. This graph does not go through 0, 0. There is that one-time fee they charge to start, right? This would be the beginning amount that we really don't care what it is. That is a terrible beginning. But what I do care is how much is it going up each time? And I know 2 points that are on this graph. So really, I'm going to treat this graph like a table. In fact, I might even make a table where X is months, right? And Y is dollars. So it looks like 5 months, it cost me $140. 9 months cost $232. And now we can treat this just like the last problem. How much is it going up each time? Well, it looks like from 140 to 232, it went up $92 in 4 weeks. So how can I, if it goes up $92 in 4 weeks, how can I figure out how much it goes up each week? That's right. I'm going to divide, right? So 92 divided by 4. Let's see, it goes in as 23. This would be how much it goes up each week. Really the same as the table I did before. And you need to do this if it does not go through 0, 0. So my answer here would be, well, I guess it's not months, it's months, not weeks, big dummy. So the answer is it goes up $23 per month is the rate of change, right? All right, so we've done well. We have one problem to go. And in this problem, we're going to compare 2 rates. So to do this, we will need to find both rates like we've been doing. Oops, you guys are supposed to have a parenthesis there. Then make a comparison between them. It looks like I want to say Jack's car gets blank miles per gallon. And I think this is going to be more or less than Jill's car. So I'm going to compare these 2 rates, it looks like. Let's see, 2 friends, Jack and Jill, had bought their first cars. You guys are close to that. The graph represents the number of miles, Y, that Jack gets. So this is Jack. Can drive his car for every X gallons of gas. The table, so this is Jill, represents the number of miles, Y, that Jill can drive her car for every X gallons of gas. I am supposed to compare these 2 rates and then make a statement about them. So let's find the 2 rates. So let's do the table first, right? We're going to see how much the Y is going up each time. It's going up by 302 every time X goes up 20. So if it goes up 302 miles every 20 gallons, how much does it go up each gallon? And of course, I would get that by dividing. 302 divided by 20 equals, and that turns out to be 15.1 miles per gallon. That is not very good mileage. Jill must have like a big SUV or something. All right, what about Jack? So Jack, now look at this, you guys. Jack's graph actually does go through 0, 0. So I'm going to talk about that in just a second. But I could still treat this like a table, and I could say 10 gallons of gas, 267 miles, 20 gallons of gas, right? 534 miles. And now I could figure it out just like I did Jill's. I could say this is going up by 267, and this is going up by 10. So the miles goes up by 267 for every 10 gallons. 267 miles for 10 gallons. How much would that be for 1 gallon? Well, I just divide. And when I divide, I get 26.7 miles per gallon. Now, the thing I wanted to point out here was this, you guys. Oops. Okay. So when it goes through 0, 0, you don't actually have to find these. When it goes through 0, 0, you can just divide the y divided by the x. Look, that's what I did anyway. 267 divided by 10. I could take any y value and divide it by the x value, and I would get the same thing. That only works when the graph goes through 0, 0. Okay, so I'm ready to answer this now. Here is Jill's miles per gallon. Here is Jack's miles per gallon. So it looks like Jack's car gets, let's see, 26.7 minus 15.1. That would be 11.6. Jack's car gets 11.6 miles per gallon more than Jill's car. And I have compared them, and I'm done. I think you can do the homework no problem. Again, you're just finding something you already know how to find, which is how much something goes up each time, right? Good luck. I'll see you next time.